This lesson is on section 5.5, triangle inequalities. We have worked with triangles several times and in several different ways, but not within the triangle itself, looking at the relationship between the angles of the triangle and its sides. We know that the three angles of a triangle have to add up to 180 degrees. But is there any restrictions on the sides? Can they be anything they want to be? Do they have to add up to something? How does that work? The rule is that any two sides of a triangle have to add up to more than the length of the third side. If that doesn't happen, it doesn't make a triangle. So here's how it goes. If you take three sides of a triangle and you add any two of them together, that sum has to be bigger than whatever the third side is. So, for example, 6 plus 3 has to be greater than 4. 3 plus 4 has to be greater than 6. And 6 plus 4 has to be greater than 3. Since all of those hold true, the triangle can have sides of 6 inches, 3 inches, and 4 inches. To make this work, you really only have to check the smaller two to make sure that the smaller two are bigger than the big one. So the only one we really have to check is 3 plus 4 bigger than 6? It would be always true that the big ones will always be bigger than the small one. But if you look at the two smaller ones, they would have to be bigger than the biggest one in order for it to be a triangle. Okay? Using that theory then, if two of the three sides of a triangle are 5 and 9, then how big can the third side be? Well, when you add 5 and 9 together, it has to be bigger than that third side. So 9 plus 5 is 14. So the third side would have to be less than 14. And assuming that 5 is small and the other one is small, when I add 5 and this number together, they have to be bigger than 9. So 5 plus what has to be bigger than 9? The third side would have to be bigger than 4. So the third side would have to be greater than 4 but less than 14 in order for it to work with sides 5 and 9. Basically, all you do is the third side has to be between the sum of the two numbers and the difference of the two numbers. That's how you get the range for the third side. It has to be bigger than the difference. It has to be less than the sum. How about within the triangle itself? How do the angle measures relate to the side lengths? The rule is the biggest angle in a triangle sits opposite the biggest side. The smallest angle in a triangle sits opposite the smallest side. And the middle size angle sits opposite the middle length side. An example, in a triangle, if it has the side lengths of 5, 7, and 10, and the angle measures are 34, 57, and 89, draw the triangle with the pieces labeled correctly. You would draw your triangle. I usually draw my angles first so that they kind of look like they're supposed to. The 89 would go here, the 57 would go here, and the 34, since it's the smallest angle, would go up here. Then my biggest side has to sit across from my biggest angle. So my side that's 10 units long would have to sit across from my angle that is 89 degrees. My side that is 7 units long would have to sit across from my angle that's in the middle, 57. And my side that's 5 would have to sit across from my smallest angle, and that's what that triangle would look like. Another example, in the following triangle, can you list the sides from the shortest side to the longest side? According to our rule, the smallest side is going to sit across from the smallest angle. So if I find the smallest angle, which is 32, the side that sits directly across from it will be the shortest side. So RQ would be the shortest side. Next would be the side that sits across from my middle angle. Since my middle angle is 46, the side that sits across from it, SR, would be my middle length side. And that would only leave SQ to be left as my longest side, and it sits across from my largest angle. That concludes this lesson. The homework is as follows.